Hi, this is Dr. Subhatra. In this class, I am going to discuss about the super plasticizers. They are the improved version of the plasticizers. When plasticizers are used, the water reduction is around 15%. But when super plasticizers are used, the water reduction can be around 30%. It is a more powerful dispersing agent, and so they are called as a high range water reducers. They can be used when the water cement ratio is very low as 0.25 or even lower. And by using the super plasticizers, we can obtain the strength up to 120 megapascal and more. Some of the super plasticizers what we can use are fly ash, slag, silica fume to make the concrete as a high performance concrete. At the same water cement ratio, they can produce much more workability. For a given workability, they can reduce the water cement ratio requirement. Okay, by increasing the strength due to the lower water cement ratio, it also reduces the the cement content. Some of the super plasticizers used are sulfonate amyline formaldehyde condensate, sulfonated naphthalene formaldehyde condensate, modified lignosulfonates, acrylic polymer based copolymer of carboxylic acrylic acid and acrylic ester, cross-linked acrylic polymer, polycarboxylate ester, multicarboxylate esters. Okay, what are the effects when super plasticizers are used? A mix with a zero slump will not show a dramatic change with the use of super plasticizer. But a slump, when the slump value is around 20 to 30 mm, it can be fluidized with the normal dosage of super plasticizers. A high dose is required when the slump is 0. See here, you can see it is a high range water reducer. When the super plasticizers are used, see the slump, how the concrete has flown. It's unable to measure the height of the concrete. So it is highly fluid and the concrete is just flowing. Not all the super plasticizers will suit for all cement. Okay, that we have to find out. We know that for finding out the workability, we have slump cone test and flow table test. But here I am going to explain you the marsh cone test. This is the marsh cone test. This is the marsh cone test apparatus. Okay, just see the picture. So, in this marsh cone test, 2 kg of cement is taken. Considering 0.5 as a water cement ratio, you can take 1 liter of water. That is a half of the percentage of water. Mix them thoroughly in a mechanical mixer. Pour 1 liter of the mix through the marsh cone, closing the 5 mm aperture with a finger. So you have to pour the mixture here and you close the aperture here by using the finger. Then remove the finger. While you are removing, at the same time start the stopwatch to note down the time taken for completely flowing out of all the slurry. This time is called as a marsh cone time. You have to repeat the same process for different dosages. Okay. Then plot the graph between the different dosage of plasticizers and the marsh cone time. The dose at which the marsh cone time is the lowest will give you the saturation point. This is shown here. Different marsh cone timings are found for different dosage of plasticizer. Here the plasticizer dosage is 0.4, 0.8, 1.2. And the flow time is, it varies from 110 seconds, 90 seconds, 70 seconds, like that you are measuring the time. So the lowest point will give, this is the lowest point, this lowest point will give the saturation point. That dose you have to take it as an optimum dose for that particular brand of cement. So likewise, we can find out for the various brands of cement, what is the optimum dosage of super plasticizer for the particular water cement ratio. Then how to find the efficiency of a plasticizer? That also we have the same procedure, same process. You can also find the efficiency. Take 2 kg of cement and take the water cement ratio as 0.6. So that you can add 1200 grams of water instead of 1 liter. Instead of 1000 grams, you can take 1200 grams. Use the admixture dosage 1% by the weight of cement. That is 20 grams. This, like the same above process, conduct the Marshall cone test and find out the Marshall time. You make the test with admixture one time and without admixture also. Conduct the another Marshall cone test keeping all the parameters same except 100 gram less water. So first time we are using 1200 gram water. The next you are reducing 100 gram less water. So continue the process until up to which point the Marshall cone time comes to the value that was obtained without admixture. Without admixture you would have obtained one value. Okay. Now repeat the same process. Reduce the water content then next to 1000 grams. Then you just compare the value without admixture and this with admixture. So at that place you just stop the test. You can find out the efficiency such as difference in the water content by original water content into 100. This will give you the efficiency of the plasticizer. So far we have seen about the super plasticizer. What is a super plasticizer? How to find out the quantity of plasticizer required for a particular brand of cement. What is the role of super plasticizer? What are the chemicals or classifications of super plasticizers? Which suits for a particular brand of cement? We can find out using the Marshall cone test. Okay. Thank you.